Hi, I'm Mr. Tarrou. In this video, we're going to be doing some more right triangle trigonometry. Or in other words, we're going to be dealing with sine, cosine, or tangent. Sokato! And we're going to be doing these problems specifically with angles of elevation and depression. And of course, I'm yelling Sokatoa because so is sine, which is opposite over hypotenuse. Ka, which is cosine, is adjacent over hypotenuse. And toa, which is the tangent of an angle, is equal to the opposite side of a right triangle over its adjacent side. So, ka toa. Okay, so we've already been introduced to the basic sine, cosine, and tangent functions and worked a little bit with this right triangle trigonometry. We're just going to be doing 3 examples with varying levels of difficulty that deal with angles of elevation and depression. Now, making these videos for honors geometry, we come back to these videos in pre-calculus. So if you're in a pre-calculus level class, these examples should be helpful, but probably won't take care of the questions you have near the end of your assignment. They can get a bit more complicated than what we're going to do in this video with our 3 examples. So I've got a couple of buildings here. I know that one is 80 feet tall. I just made up these numbers. I don't really know how, if that's a good height of a building or not, but it's what we have. And from that building, we have, and we're going to assume that they're on horizontal or level ground, that in comparison to each other, we have this horizontal line. And angle of elevation is how much you have to look up at something. Okay, you're elevating your point of view to see something else. So you're looking up. And angle of depression is simply looking down off of horizontal based on wherever your eye level is at. And right now we're just going to say we're at the top of this 80-foot building. If the angle of depression is 32 degrees, so we're going to focus in on this little angle here being 32 degrees, how far apart are the buildings? So what I'm going to do is just draw a quick little right triangle here. We know that this building here is 80 feet across. Now, I've got an angle of depression. I'm looking here over at the other building, and I want to find out how far away the other building is. Well, that means I want to find out how far apart, the buildings are. So I'm looking at that horizontal line right here, and that means that this length here is going to be our unknown value of x. Well, I'm not going to be able to solve for x unless I get some more information about this right triangle. Now, I'm looking at this right triangle right here coming from our point of view horizontal to the other building, and hopefully that building is, perpendicular or straight up and down. So this is going to be a 90-degree angle. And, I'm going to go ahead and take this 80 feet that really doesn't appear to be part of this triangle and, of course, transpose it over to the other building. That's what I'm talking about as far as purposes of this example. Our 2 buildings, the base of our buildings are on level ground as well. They're the same height. It gets more complicated if they're not. You might have to do law of sine or law of cosine for those kind of problems. So these 2 bases of these buildings are level across each other. Angle of depression looking down or angle of elevation looking up is always off of horizontal. And that means that this side over here is 80. Okay, if you just found my videos, I like to emphasize that, we are going to be doing, again, right triangle trigonometry, which means we're going to be dealing with sine, cosine, and tangent. And as you look at your diagram and you're trying to decide what trig function you're going to use, I like to first identify what angle we're dealing with. We always name the sides of our triangle, again, with one of the acute angles, never with the right angle in our right triangle. And you want to name those sides of the triangle based on the angle we're going to use. So I want to use this angle that's marked off as 32 degrees. So this length that I've marked off as 80 feet is the opposite side. The side opposite 90 degrees is the hypotenuse, and the leg that is helping to make the angle that you're going to use in your problem is the adjacent leg. It's extremely important. It's extremely important for you to name the sides of the triangle before you start the problem. Because if I were using this angle here on the bottom right-hand corner, well then this would be the opposite leg, and not the adjacent leg. So the names on those legs are dependent, one more time, on the angle that you're going to use to do the problem. So now that we have the triangle properly named, we want to decide sine, cosine, or tangent. Well, what do you have and what do you want? And I'll repeat that through the whole video. What trig function are you going to use? Well, what side do you have and what side do you want? Well, I have the opposite side and I want the adjacent side. Well, opposite and adjacent. So sine's opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So based on what I have and what I want, the opposite and adjacent, we're going to use the tangent function. So the tangent of 32 degrees is equal to the opposite over adjacent side of 80 over x. You cannot solve for a variable when it's in the denominator of an equation. Never, really, basically. That's the rule I like to say when I'm teaching. So we need to get that x out of the denominator. So we're going to multiply both sides by x. And what I'm doing is, this is 80 divided by x. I don't want that division of x. I don't want x in the denominator, so I'm doing the opposite division, which is multiplication. And of course, you know, that's fine as long as you do both sides of your equation. So now we have x times the tangent of 32 is equal to 80. I have x times the tangent of 32, so I want to undo that multiplication. Now that I have the x out of the denominator and have it up in sort of like the main line of the equation, I want to undo that multiplication. I'm going to do that with division. So I'm going to divide both sides by the tangent of 32. That tangent of 32 divided by tangent of 32, anything divided by itself is 1, so we just have simply x is equal to, and this is going to have to come out of your calculator, and I'll have to refer to my notes for that. Since this is the first example, and I'm kind of going slow, I understand, and I'm hopefully helping you, not boring you here. Whenever you touch the sine, the cosine, or the tangent button on your calculator, you need to make sure that it's in degree mode. Now, if you're just in geometry, like how I'm, that's why I'm doing those videos for my geometry students, your calculators are probably going to be already in degree mode. But if you're doing pre-calculus or trigonometry, you switch back and forth between radians and degrees. A radian is another way of measuring rotation. So you want to make sure that if you touch the sine, cosine, or tangent button, your calculator is in the proper degree mode. Otherwise, it doesn't make any difference, and for the purposes of these questions. This is degrees, and I want to make sure my calculator is in degree mode. And enough of that talking. 80 divided by 32 degrees is approximately 128 feet. Now, I say approximate because the tangent of 32, when you take the tangent of almost any trig function of almost any angle, you get an irrational number. It just runs on forever, never repeats and never ends. So there's always some level of rounding off. And because my problem gave me a measurement that's just simply 80 feet, it's not super specific. I don't know if it's really 80.02 or something like that feet. It's just rounded off to 80 feet. I've rounded this off to 128 feet. Okay, so that's how far apart the buildings are. And let's just put that right there. Now coming over to part B, I'll start speeding up these examples. If the angle of elevation is 23 degrees, how tall is the building on the right? So now what I want to do is focus on the fact that we're looking up, and our angle of elevation is 23 degrees, and I want to find out how tall this building is on the right. Well, I already know that this length is 80 feet from over here. All I have to do is find out how tall this piece of the building is, and let's just call that y. I don't think I've used that variable yet. We're going to find out that length, and then simply add these two lengths, and we'll know how tall the building is. So I'm going to have to use this information of the fact that the buildings are 128 feet apart. That little hatch mark stands for feet. If there were two of them, it'd be inches. And we're going to solve for y. Well, again, what do you have and what do you want? Well, if I'm using this angle of 23 degrees as angle of elevation, then this is the adjacent side. This is the opposite side, opposite the 90-degree angle. is always the hypotenuse, and I have the adjacent side. I want the opposite, adjacent, opposite, opposite over adjacent. That's tangent again. So the tangent of 23 degrees is equal to y over 128. Now with this one, my variable is in the numerator, so it's going to be a little bit less work to figure it out. All I have to do is multiply both sides by 128, because again, I want to undo that division. That multiplication and division cancels out, and we get y is equal to 128 times the tangent of 23. Now, you're going to put in the calculator, well, depends what kind of calculator you have. You want to do the tangent of 23 degrees. That's the size of the angle. Find that answer first and then multiply by 128. If you have a two-line scientific calculator or maybe a graphing calculator where you can see the numbers and variables and all that, well, not variables, but math functions as you type them into the calculator, you can just do 128 times tangent of 23. It'll give you the right answer. What you don't want to do is do 128 times 23 and then take the tangent. That'll be very, very wrong. The tangent function is applied to just the angle measurement, and the angle measurement is 23 degrees. So 128 times the tangent of 23 is approximately 54.3 feet. I have a feeling that I only rounded it off to the tenths. I have a feeling this must have been, I don't remember exactly what I got out of my calculator, but that must have been really close to 128 because I'm just using my notes here. If your teacher's really stressing the significant digit idea, and really you're not supposed to represent any calculated values to be any more accurate than your measured values. So if we wanted to be strictly, super strict on this, your teacher might want you to be rounding this off to 54 feet to have it appear to be no more accurate than the given level of measurement of 80 feet. I'm going to just go ahead and keep the decimal though, not worry about that. Now the overall building then, if this is 54.3 feet, then of course we have the two parts of the building, and the overall building is going to be, well, 54.3 plus 80, and 8 times 5 is 13, so 50 times 80 is going to be 134.3. Excellent. Okay, now we want to stop and read this. We'll set up the diagram, then I have to erase the chalkboard because I'm running out of room. But someone in a hot air balloon, 1,300 feet in the air, needs to look down. That would be an angle of depression of 6.5 degrees to see you. How far are you from the hot air balloon? Very common with application problems. As you get into the harder ones, they will not give you the diagram. They'll just give you a word description of the problem, and you have to come up with that picture yourself. So I think it's pretty obvious. We have some ground. Ta-da! And you're down here, chilling, kind of skinny. And there's a hot air balloon. Little basket, not very well drawn, but good enough. And that hot air balloon, you are told, is 1,300 feet in the air. Now, the way you measure the distance between a point and a line, the line being the horizontal ground that we're standing on, if we were going to be assumed to be sort of standing on a hill ourselves and then looking up, or having someone in a hot air balloon looking down, that would not be a right triangle, and we would need to use law of sine or law of cosine to solve the problem. And we're just doing right triangles here. That person is looking down at you. So for them to see you in the basket, they're having to look down an angle of depression of 6.5 degrees. So that 6.5 degrees must be them up in the hot air balloon, like the problem says, looking down at you. And barring some problems with my drawing, we're assuming against, because we're doing right triangle trigonometry, that we are standing on level ground. Angles of elevation and depression are always off the horizontal as well. And what that means is we have 6.5 degrees in our diagram. Well, that 6.5 degrees is not inside of our triangle where we can use it. But if this ground is to be assumed to be horizontal, angle of depression is off of horizontal. That means that these two line segments are parallel. And once again, if you have parallel lines being cut by a transversal, that Z shape, which we can often find, is one way of identifying alternate interior angles. In alternate interior angles, when two parallel lines are cut by a transversal, those alternate interior angles are going to be equal. So that means that the 6.5 degrees can be brought down into the triangle, and we can, use it. Okay, now before I erase the rest of this board, how far are you from the hot air balloon? That's a little bit vague on the wording, so let me clarify. I don't want to use the, basically I just don't want to use the tangent function again. So I want to be like directly, like not if you were to walk over, how far would it be for you to be directly underneath the balloon, but like specifically, if you were to pull a string, how far are you away from that person in the hot air balloon? So we're going to be finding out this value here of x, which is going to be the hypotenuse to the right triangle. So as I pause the video, why don't you get these sides named and even try the problem out yourself, because this will be done very quickly once you get the board erased. Bam! Thanks for watching. Ta-da! Okay, anyway, whatever. Got the chalkboard erased, and I've labeled the sides. So again, based on what do you have and what do you want? Based off the 65 or 6.5 degree angle, we have the opposite leg. We're looking for the hypotenuse, opposite hypotenuse, so katawa. That would be the sine function. So the sine of our angle measure, which is 6.5 degrees, is equal to the opposite side of 1300 over a hypotenuse of x. Again, you cannot solve for a variable that's in the denominator. Now, I prefer to just multiply both sides by x. You can go ahead and pop this over 1. It's going to do the same thing anyway, and show that both sides, that this, you can write this as a fraction, and show that there's one fraction on each side of the equation and cross multiply, which is fine as well. But at any rate, the x is going to come out of the denominator by doing the opposite of that math operation. So we're going to get x times the sine of 6.5 degrees is equal to 1,300 feet. We're going to divide both sides by the sine of 6.5 and get x is equal to, right off the top of my head, if I can find it, it's on the next page, 1,300 divided by sine of 6.5 is 11,483.8 feet. And that is approximate. And if we, I think I'm pretty safe assuming that that hot air balloon is not exactly 1,300 feet, so it's probably rounded off the nearest foot. So we would say that this was approximately 11,484 feet. Rounding that up, of course, because 8's 5 or bigger. All right, I got one more example before we're done with the video. Woo! Last example, right here. Now, if you're in Algebra 2 Honors or Pre-Calculus, you're going to have problems that with this sort of similar looking diagram, but based on like what parts of this diagram you're looking for, it can be much more work than we're going to do in this particular problem. And I have videos or examples like that in my Pre-Calculus videos. What we're going to do though is we're going to, for the first time in this video, actually find an angle of a right triangle, and then we're going to find this little piece here of length x between this angle and this angle. Okay, so the first thing we want to do is find the angle of elevation, and specifically of A. I have two angles of elevation here. I have, if I'm way back here, I can see my angle of elevation from the level ground up to 207 feet above is 41 degrees, but I want to find this angle of elevation here, angle A. So, if I'm going to do that, I'm going to have to be able to determine what type of trig function I want to use. And that means I want to, with this inside triangle, identify that this is my adjacent leg, my opposite leg, and my hypotenuse. So again, our examples here have us using tangent. From A, I have the opposite side. I also have the adjacent side, but unlike the previous problems where I had the angle measure, this time I'm going to be looking for it. So I'm going to use a tangent function to find angle A because of the two sides that I have in this particular triangle. If I gave you this length of 207 and I gave you this length up here where you had the opposite and had the hypotenuse, well then you'd be using the sine function because that sine is of an angle is opposite over hypotenuse. But we have opposite and adjacent, so the tangent of A is going to be equal to, remember you put an angle measure into a trig function and you get out the sides of a triangle, and that's going to be opposite over adjacent, which is 207 over 98. Now, can't do all this in my head, so 207 divided by 98 is 2.112. So the tangent of A is 2.112. Now, I want to get that tangent function away from the A so I can solve for that unknown value. Well, it's a tangent function, right? So whenever you want to undo a function, you must apply its inverse function. In the previous video where I was trying to get, say, x out of the denominator, it was something divided by x, so I had to undo that division operation, math operation, by doing the inverse function, which is multiplying. If I want to get the tangent away from A, I can't divide both sides by tangent. That wouldn't make any sense because tangent itself is a math function. I want to do the inverse math function, and that means that A is going to be equal to the inverse tangent of 2.112. So this little negative 1 on your calculator, if you've studied, I'm sure you have, negative exponents, you know that something like 3 to the negative 2 is equal to 1 over 3 squared, and that becomes 1 over 9. Well, when you talk about functions, this little negative 1 in the exponent does not mean I want to find the reciprocal. It is an inverse math operation. So whereas a regular trig function, you put in an angle and get out the sides of a triangle, with an inverse trig function, you're going to put in the sides of the triangle and get out as an answer the angle measure instead of what you normally do, which is you put in the angle and get out the sides of the triangle. So the inverse tangent of 2.112 is 64.7 degrees, approximately. Okay, now that makes sense from our diagram because if I'm here and I have to look up 61 or 64.7 degrees, you know, as I get closer to a building, I have to look up and up and up and up more and more and more. But as I move back, the building, it appears to be smaller, right? Because it's going to get smaller as you move farther away. So if I step farther back to look up at this top, which is 207 feet above, let's just call it the ground, I'm not going to have to physically strain my neck as much to look up. So this angle of elevation should be less than this angle of elevation here, and indeed it is. Of course, 41 is less than 64.7. So I'm just kind of giving you some kind of way of identifying if this number is even reasonable. Now I want to find out what x is. I'm not going to need the 64.7. These problems are really kind of independent of each other. And I want to find out what x is. Well, x is only a piece of this bottom side, or it's only a piece of this leg. Now, that means that we do have this obtuse triangle out here on the left, and in trigonometry or pre-calculus you'll learn something called law of sine and law of cosine that allows you to deal with non-right triangles, but we're only in geometry honors, and so, or at least that's what I'm doing this for, so we don't know that yet. What that means is, if I'm going to identify what the measurement or the length of x is, I'm going to have to still work with this large right triangle, and we're just going to find the length of this entire leg, and we'll call that y. We're going to find that entire length and then simply subtract out the 98 feet. Well, it's the same design here from 41. This is the opposite side, and this is the adjacent side. So again, what trig function to use? I guess I should have made too many examples using tangent, but what do you have and what do you want? What do you have? What do you want? Opposite, adjacent, tangent. So the tangent of our angle measure of 41 degrees is equal to opposite, which is 207, over the adjacent side of y. Multiply both sides by y to get it out of the denominator again. Divide both sides by the tangent of 41. And y is equal to 207 divided by tangent of 41 is 238.1 feet. And that again is approximate. So if the entire leg is 238.1, then x, make sure you answer the question. We are only looking for the small segment here. So x is going to be equal to 238.1 minus 98. Okay, so the subtraction thing without being completely dependent on our calculator. Well, clearly the 8's are going to cancel out. 8 minus 8 is 0. 230 minus 90 is going to be 140. So we have 140.1. 140.1 units. Whether this is in feet, miles, inches, I don't know. But I do know this is the end of my last example. So, I'm Mr. True. Bang! Go to your homework.